channel, another name is B suffix M channel, and signaling channel which is D suffix M channel. So basically your physical layer is same as that of your OSI layer, including functions, everything. The second layer, data link layer, here it is called as LAPDM, which is link access procedure on DM channel. Above that is the layer 3, and here layer 3 is 3 different parts. So that we'll discuss it one by one. So basically here, architecture plane, as you see in this reference model, which is a 3-dimensional view. So you have the topmost layer as management plane. Basically, you know that management plane which will manages all the activities with respect to your GSM system, basically which is nothing but your operation and maintenance center, OMC. So management plane mainly take care of your OMC block with respect to connection between two MSCs, connection between MSC and GMSC, MSC with ISC and all those things. So below that we have one plane which is your control plane and as well as user plane. Even in the 3-dimensional view, you can see here the very basic layer is physical layer. Physical layer remains same thing, whether it is a control plane or user plane, physical layer remains the same thing because which basically provides end-to-end connection, error detection, correction and all those things. So above that, you have your traffic channel. Basically traffic channel, you know that it is used to carry the user data. That is the reason it is mentioned below the user plane. Below user plane, you have traffic channel because basically it is used to carry data as well as speech. That is the reason. And control plane, in order to control the other activities, that is communication with respect to different layers with respect to GSM, you have other channels, which is a broadcast channel, command control, as well as dedicated channel. It is nothing but under your control plane, all your signaling channels will come into the picture because signaling channel, it is classified into 3 types, BCH, CCH, as well as DCCH. All these things will come under your control plane. So basically control plane will take care, uses the corresponding signaling channels. User plane will use the corresponding traffic channels. So generally your protocol architecture depends on both the types. One is your protocol architecture in user plane. Another one is protocol architecture in signaling plane. So user plane is, we are restricting ourselves only for physical layer, maximum up to your the second layer, LAPDM layer. Whereas in case of signaling plane, we are going to discuss all the things starting from your physical layer till the topmost layer, which is your management plane. So we'll discuss one by one. So here you can see. So this is your protocol architecture in, actually protocol architecture in your user plane is this one, that is this diagram, where you can able to see, as I told, user plane mainly will restrict how the user data is communicated within the GSM system. So you have your MS. Basically, we already know that it starts communicating from MS to BTS. In turn, BTS will communicate to BSC, and BSC will communicate to MSC. And we have interfaces also in between. We have the interface from MS to BTS is a radio interface. Again, you have from BTS to BSC, you have your UM interface. Followed by that, BSC to MSC, you have your A interface. And also we know that there is no direct communication between MS to MSC. It has to follow this path. So here in the user plane, so here in this part mainly there are chances they'll ask 2 different questions. One is protocol architecture in user plane, another is signaling plane. So what we are discussing now, it is only with respect to user plane, how the user data is communicated over GSM layers. So basically here, as already we know that there are 2 different types of signaling. One is GSM specific signaling, another is ISDN specific signaling. GSM specific signaling, which will basically use your radio interface, that is between MS to BTS. Again, from BTS to BSC, it will make use of the corresponding UM interface in order to communicate the data from, whether it is speech or the data from MSC to BSS. Generally, instead of writing separately BTS and BSC, we'll take that as one system, which is called as base station subsystem. Again, any data from base station subsystem, if you want to communicate to MSC, we'll make use of ISDN specific signaling. So here we'll use the corresponding protocols, whether it may be your ISDN UP or whether it may be MAP, or whether, as you know, that MAP can be used only by MSC. Equivalent protocol with respect to BSS, we have BSS MAP. So related protocols we're going to use between this BSS as well as MSC, which is under ISDN specific signaling. So this is basically a very simple diagram with respect to user plane. where it communicates from MSC to MS to MSC. So in detail, if we take up this, so here you can take up this diagram. So how actually, because I already have told that here I have written radio interface which is from MS to BSS. So how actually it functions? With the help of channels, we can able to have this diagram. So we know that here DM channels are nothing but signaling channels. BM is nothing but your traffic channel. So anyway, user data, whether it is a speech or data, can be communicated only with respect to TCH, that is your traffic channel. So here you can able to see in this diagram, I have written only layer 1, layer 2 and layer 3. Layer 1, as I told already, it is your physical layer. Layer 2 is your LAPDM, link access procedure on DM channel. Layer 3, which is a combination of RR layer, MM layer and CM layer. All the three will be taken as one layer in case of cellular communication. So together if you split, it will be 4 to 5 layers. But as I told, together the topmost layers RR, MM and CM layer, they're going to combine it as one. RR is radio resource management layer. MM is mobility management layer, CM is connection management layer. All the three are combined together and it is called as the topmost layer in case of mobile communication. So layer 1, which is your physical layer. In your physical layer, basically it is going to use your traffic channel in order to transmit user data. That is what here it is mentioned, TCH. TCH is used in layer 1 in order to transfer user data. So user data will be transmitted only with the help of this traffic channel from layer 1 to the topmost layer, which is your layer 3. It will not use any other channels in order to transmit user data. Similarly, signaling channel. As already I told, you can make use of first preference will always be given to corresponding associated or dedicated channel, because you know that dedicated channel will function independently and associated channel will function along with your TCH. Already anyway we have, in order to transfer our user data, we have our TCH. That is the reason under signaling I have specified only two other channels here, SDCCH and SACCH. I have not specified any other channels here. It is because standalone will function independently and SACCH will function along with your TCH. That is the reason we need not to specify all the channels here. Anyway, we have in next class we'll discuss one more diagram with all the other channels. But here, as I told briefly, we are discussing with respect to user plane. Hence, we'll take only associated or dedicated channel under signaling and traffic channel under corresponding traffic. So as you know that if you have, if at all, in case of BTS or a base station subsystem, it has to multiplex the signal. It is going to receive so many signals, but it is having only one path. So for that reason, basically, even you know that in case of data link layer, it is going to perform your multiplexing. Similarly, here layer 2 will use your multiplexing here. So under multiplexing, you have your S and P here. So S indicates it is your signaling data. P indicates it is your payload data. Can you tell me what is the meaning of payload data? It means that after receiving the information, that is from layer 1, it is going to multiplex the signal. It means it is going to combine your data which it is receiving from your traffic signal along with your associated and dedicated channel. After multiplexing, it is going to separately transmit signaling data. Separately, it is going to transmit your payload data. Payload data, another name for user data is your payload data. User data and payload data both are one and the same. Whatever you have your user data, another name is your payload data. So in layer 2, it is going to multiplex both signaling as well as user data, and then it is going to transmit the corresponding signaling data as well as payload data. That is what is the meaning of this. So basically, this is what is under user plane. As I told, user plane will restrict ourselves only for layer 1 and layer 2. We are not going to discuss the topmost layer, layer 3, under your protocol architecture of user data. So under user plane, you need to write these two diagrams, how it is going to transmit from MS to MSC in brief, followed by that layer 1, layer 2, layer 3, what actually it is doing in layer 1. Layer 2, it is going to combine, it is going to multiplex the signal. Separately, it is going to transmit signaling as well as payload data. This is nothing but under user plane. You have one more diagram, which is